Information design is a field of information visualization, and it's there to help you find the most efficient method of constructing a visual language. It is all around us, in digital interface buttons, graphs, forms, and even road signs. With it, we can start to understand how people process patterns and shapes, how the symbolic is created out of the geometric, and how the geometric is created out of the symbolic. Take for instance time. Time can be visualized in many ways. Generally, when it comes to conceptualizing time, we can do it by categorical means or continuous means, like a clock with rotary pointers and numbers representing fragments of time through the day, or as digits, which is used on most digital surfaces for its numeral clarity and convenience of space. There's also dates, like days of the week, or weeks or months of the calendar, or years. Time can also be visualized as cyclic, such as with seasons, where the 4 seasons loops back over each other and is not expected to change. But when we are visualizing years, we cannot visualize time in this manner, as the year 2016 will not come back anytime soon. When combining both cyclic and linear means of visualizing time, we end up with visualizations which are not practical, although they are perceptual. Our understanding of time can be visualized in many ways because we don't really perceive time with our visual senses. We don't naturally have a mental model of how time works or what the actual speed of time is. All it takes is a system within the visualization that we can understand. But the takeaway here is that a clear visual language allows society as a whole to have a shared understanding of time, which can be mentally processed without too much cognitive load. And this is why information design is important, and definitely why user testing is one of the most crucial practices in the development of your project. A collective society's model of time can to a great extent be different from one another based on the teaching material that is collectively taught, but even as individuals we have a very different ways of visualizing time in our heads. User testing can be a good way of learning how your users understand not only time, but pretty much anything. A great experiment on the model of time was conducted by the Norwegian Broadcasting Corporation, where they surveyed how people visualize the year by its months in a cyclic manner. Here's one example of what the year can look like, but already there's probably some of you who disagree with the placement of January in this instance. You might think it should be on the very top. But take these two charts as an example. Just by isolating December and March, the participants in the test had a wide disagreement in where to place these months. And at first, it might be easy to discard the odd ones as survey sabotage, but the actual reason is a lot more interesting. What it comes down to is that the participants had a different idea of the direction of the year goes along the eclipse. And some think December should be at the bottom instead of the top. But for some, this visualization method is too simple. Some feel the need to account for the perceived lengths of the months. In this case, July and August takes up a quarter of the year alone. Some also perceive the year as a three-dimensional cylinder, and then there are even some who have a locked perspective from which they see the geometric representation. Then there are some who cannot visualize the year without seasonal associations. But even seasons can be understood differently outside the usual spring, summer, fall, and winter cyclic pattern. The Sami conceptualize the seasons as overlapping periods, and the wording of the seasons can be crucial in understanding their visual model of the seasons as well. In the case of winter, the word winter is never the primary in the overlapping periods. There's fall winter, winter, and spring winter. However, spring is always the primary, as shown in spring winter, spring, and spring summer. So in this case, if we intend to visualize them in a linear manner, we probably cannot visualize them like this. We probably need to visualize them like this. And even here, people will perceive the motion moving past the visualization as either wavy or linear. So when we're dealing with information design, we are dealing with 8 visual variables according to Burton, Cleveland, McGill, and McKinley. The 8 variables are focus, position, size, value, texture, color, orientation, shape, and dynamics, or motion, where we move the visual out of the staticness into something evolving and changing within its borders. These visual variables can be mass applied to even the simplest of graphs. Take this graph found on the iMac page at apple.com. Although it is really simple, it utilizes many of the visual variables to infer a meaning. The small text implies a topic and context. It uses position and size on each element of the graph. It uses value by the means of the enlarged number, or uses shape, size, orientation on the graph bars. And the number and the graph bar is the same color to communicate that they are contextual. By the principles of the 8 visual variables, you can create an enormous canvas of visualization. The problem is that just as we as individuals develop much of our oral and written language through association and not theory, largely we also individually develop our visual language through which we interpret and understand visual concepts. Your perception of the meaning of the visual element will not be the same as any other person observing it in the wild. There will be similarities in the interpretation of it, but there will be differences in how they memorize it and what they associate with it. They may use their understanding of it in another context than you intend. But there has been attempts at developing a worldwide visual language through an initiative which lasted from the 1920s till the 1970s, and it was called Isotype, which is an acronym for International System of Typographic Picture Education. In short, what Isotype is a system of graphic presentation of information, which may go under the term data graphics. The sum of the work should supposedly consist of hundreds of rules, and somewhere out there should be an archive listing them all. But the original prints and books of the authors behind Isotype is challenging to find and expensive to purchase. But literature which discuss Isotype sums it up into a few core principles. In an attempt to maintain an honesty of representation, pictograms representing numerical data are repeated and not enlarged. Isotype is a form of popular science and education visualization, so precise metrics was not really needed for the purpose of it. And according to Otto Neurath, one of the core Isotype practitioners, reasoned that remembering simplified data graphics is better than to forget precise numbers. Information needs to be presented in an easily comprehensible way. According to the Isotype practitioners, viewers are not able to grasp and remember subtle differences in color, so Neurath appropriated 7 colors to use in Isotype designs: white, blue, green, yellow, red, brown, and black. Pictograms should always be rendered isometric, meaning there is no perspective warping. If the icon is of a cow, the furthest away leg will be as big as the closest leg. The language of headings and captions in charts are simple and not characterized by emotion. This again comes back to maintaining some form of honesty of representation. By avoiding sensationalism in the paper, there is less chance of word association to give biased meaning to the data. They also made a natural ordering of data. For instance, time should be illustrated as moving downwards on the surface, and geographical positions such as countries should be arranged from west and then graduate eastwards from the top of the surface moving downwards. So the westmost country is at the top, the eastmost country is at the bottom of the surface. If we compare the process and principles found in Isotype and the infographics approach, Isotype was intended as an international standardized visual language which would be able to lay a foundation of a very closely shared understanding of data graphics. Today's infographics and its lack of formal principles creates a visual language which cannot be commonly understood between the creator and the viewer. The problem arises individually through associations and in masses through culture. Another pitfall is that it may end up in designs where the style is more developed and considered above the functionality and understanding of the design, both on an individual level as well as en masse. In this case, it is up to the designer to both create the visual language while being able to predict how the viewer will understand the visual language. Luckily, people in general, including designers, are limited in what they can really invent, and can at best reinvent or iterate on existing concepts they are aware of. So as the current tropes of infographics designs has been established by a few, they've been copied over and over and over. So what we're left with is still a form of visual language. The problem is that it's not really governed. When considering that the reach of graphical designs are often international these days, consider the situation where a radio broadcast in English would be broadcasted across Europe. But in this situation, English had never been formally taught in school, and actually there were no formal grammatical rules or dictionaries at all. People just copied words they happened to hear around them and understood them individually through context. This is in essence infographics. It is a problem in all visual languages, including icons, even comic strips, but infographics is a particular victim of this because of its heavy emphasis on style and architecture. All that being said, we can clearly identify certain principles and visual laws inherited in infographics from Isotype. But it is more effective to take note of those which has not been inherited. In infographics, they often use scale as a means to illustrate differences in numbers, and they will also often use exact numbers. This already breaks two of the principles of Isotype. Now you're probably curious if there is some sort of blueprint in how to visualize information perfectly every time. Some sort of blueprint can be found by extensive user testing for certain people, as visual languages vary from individuals to individuals and culture to culture. The first step is to learn various principles which you can use as guides which will lead you through the user testing phases, and if the principles are verified, it becomes easier to create blueprints. You can learn about principles through various authors who writes within the subject or field, who sums up research papers into theories and so on. Or you yourself can read research papers and create principles and models for yourself. You may, for instance, be curious about the use of hamburger menus, so you search for articles and end up with works like Comparison of Hamburger and Bottom Bar Menu on Mobile Devices for 3-Level Navigation, which presents to you data such as this table, and then you'll reflect on it and create principles you can use as you work. Anyway, when you start reading in on subjects, be it information design or anything else, you will eventually forget the 99.9% of the word-by-word information that's there. But you create models in your head that compiles the theory down to principles that is very easy to remember and generalize them into a wide range of use cases. This is what will make you a great designer, your ability to know principles of design and where to correctly apply the right principles. So just think of topics, questions, research for articles regarding it, and find books on the subject. Like this video, you won't find blueprints because blueprints in design are most of the time a one-case use. If you are making a mobile app for fitness for kids, you won't be able to use those blueprints for a mobile app for fitness for adults. Kids have another way of understanding icons, text, illustrations and so on than adults. So a truly efficient design for kids can never be as efficient design when it is used by adults. It will work, sure, but there will be grounds for heavy cognitive load in the use of the applications for the adults in this case. So I hope this video summarized why you as a designer will find a lot of use for the theoretic field of information design.